Welcome to webinar 2. This webinar is a part of a project funded by the European Union Seabridge program. So in this webinar, we are going to examine recycling and circular economy in composite materials. So we know that the recycling of composite is generally a more complex process and also expensive process compared to traditional uh, structural materials. Additionally, composites are difficult to decompose in nature, so they can lead to a large amount of waste accumulation. So that's why the importance of the circular economy approach uh, becomes critical in the industry. So circular economy is a model that aims to use and recycle and then reuse the products for a longer period of time. The integration of this model in the composite industry both will reduce the environmental impacts and also will increase the resource efficiency. So we will discuss the importance of recycling in composite materials. We will also focus on recycling methods and strategies for the transition to a circular economy. Additionally, the challenges that might be faced in achieving sustainability goals in the composite industry and the opportunities also in the area will be uh, discussed. So let's start with the importance of recycling in the composite industry. So composite materials are preferred in many industries due to their exceptional properties. But on the other hand, the environmental impacts of these materials can uh, cause many problem in the environment. So recycling of composites becomes very critical, very important in terms of the environmental sustainability. So that's an important part, the recycling of the composite materials. So when we look at the environmental impacts of the composites, um, we can subdivide this section into three phases, such as production phase, use stage, and the stage after the end, which is end of use stage. So in the production part, the production of composite materials is generally an energy intensive process. The production of high performance materials such as carbon fiber requires significant energy consumption. In addition, the environmental impacts of the chemicals used in the production of composites cannot be ignored. This high energy consumption in the production phase will increase the overall environmental footprint of composites. In the use stage, composites generally have minimal impact on the environment during their lifespan due to their long-lasting and durable materials. However, when these materials reach their end of life, recycling challenges cause to environmental problems. As a last stage, which is called end of use stage, composites that have reached their end of life will be very difficult to decompose or reuse in nature. So that will create a serious waste problems, especially in large size composite components such as automotive and wind turbine blades. Moreover, these wastes usually accumulate in landfills uh, and will create an environmental burden. So in order to minimize the environmental impacts of composite materials, so it's of great importance to develop recycling processes and adopt more sustainable production methods. So the role of recycling in the sector. Uh, so in this part, we can say that the recycling of composite materials is important in reducing environmental impacts. Um, So we can also say that production of natural resources will be achieved by recycling of the raw materials. This prevents the depletion of natural resources at the same time. Although the recycling of composites is more limited compared to traditional materials, the recycled fibers and resins used in the process can be transformed into new materials. Recycling generally requires less energy than raw material production. The other parameter that we can discuss is the waste management. Recycling of composite enables the processing and disposal of large amounts of waste, especially large composite waste generated in the aviation, automotive, and wind energy sectors are recycled and then reduce the need for the landfills. At the same time, there is a potential to contribute to circular economy in the composite industry. Um, so recycling of composite contributes to the basic principles of the circular economy model. A circular economy is a production model that aims to reprocess, recycle, and reuse materials after they have been used for, for many time. So this model is based on the principle of reduce, reuse, and recycle, and is the key to increasing the sustainability in the composite industry. The potential to contribute to circular economy in the composite industry can have many pillars such as resource efficiency, reduction of waste, reducing carbon footprint, new business models and stuff. So let's start with the resource efficiency. Circular economy enables more efficient use of raw materials. Recycling of composites allows limited natural resources to be used for a longer period of time and reduces the need for new raw materials. At the same time, recycling of composites reduce the amount of waste and minimize the waste in the production phase. So that's not only provides the environmental benefits, but also creates a more economically efficient production processes. The other benefit of the circular economy model helps reduce energy consumption in the production processes and therefore carbon emissions. So recycled materials have a low carbon footprint than materials produced from scratch. So recycling of composite materials plays a critical role in reducing environmental impacts. Recycling both protects natural resources and also saves energy. So the integration of the circular economy model into the composites industry will provide more sustainable production methods and more efficient use of natural resources. And at the same time, this model will offer a great opportunity to reduce the environmental footprint of the sector and achieve the sustainable development goals. When we look at the recycling methods, we will see three main methods that are used in recycling. Those are mechanical recycling, thermal recycling, and chemical recycling. Mechanical recycling allows the recovery of composite materials through physical reprocessing. So this method is usually a less energy consuming and simpler process. Composite materials are made usable again through physical processes such as grinding, cutting, and crushing. So after these processes, the parts will be separated mechanically In the separation method, separation is made between the matrix and the fiber of the composites. For example, a glass fiber, reinforced plastic composite, can be separated by physical means rather than chemical or thermal processes. So in this way, the fibers can be reused while the matrix material can be further processed for recycling. When we look at the advantages of the mechanical recycling, we can say that it has low cost, simple application, and it has fast processing. But low quality of the recycled materials and the limited area of use can be mentioned as the disadvantages of the mechanical recycling. For the thermal recycling, we can say that that method involves the process of heating composite materials at high temperatures and decomposing the matrix material. This method is widely used, especially in the recycling of thermoset composites. Thermoset composites are resistant to heat and chemicals, so they cannot be reshaped. However, these materials can be made reusable with special thermal cycling methods. Uh, with this method, it could be possible to recovery of the fibers and the process of the complex components, but as a disadvantage, we can say that they will require high energy requirements, high energy sources, and very limited application in terms of materials type. The the other part of the other methods for recycling is the chemical recycling. So it's the chemical process of separating the matrix material of composite materials. So this method is particularly suitable for thermoset composites as these materials cannot be reformed by heat as mentioned before. Uh, so chemical recycling processes are carried out using liquid solvents and special chemicals. In this method, we can say that the fiber quality will be preserved and it can be applied to a wider range of materials. But as a disadvantage, we can say that it has high cost, and since the process requires chemicals, safety procedures will be an important factor for this material. So in this method, in this part, we can also discuss the strategies for transition to circular economy in the industry. Uh, Transition to circular economy in the composite industry offers significant opportunities to reduce the environmental impacts, and also, as mentioned before, will expected to increase the resource efficiency and to achieve the long-term sustainability goals. One of the methods that can be transfer or transform the composite industry to circular economy approach is eco-design approach and sustainable product design. Um, that method, eco-design method, it aims to minimize the negative impacts of the production to the environment in the design phase. So in the composite industry, eco-design considers sustainability goals at every stage from material selection to production processes. So this approach aims to reduce the environmental impacts, negative impacts of products by evaluating every stage from production to post production. So the basic principles of the eco design starts from the material selection. So the environmental impacts of the materials to be used in the production of composites should be taken into account. For example, using biodegradable and recyclable fibers. Also, selecting matrix materials could be mentioned in this stage, and also long life design. It's important to increase the durability of composites and ensure that they produce less waste throughout their lifespan. Could be a parameter to be used in the eco design. Easy recycling is one of the parameters that can be used, and also energy efficiency that can be modeled in the design process of the structures made of composite materials could be a crucial step for the eco design. Um, the main aim is to design a sustainable product. So main advantages of the sustainable product design could be reducing energy and resource used in the production processes, and also products that have a longer lifespan and less waste, um, and also products that will be easy to recycle uh, after the eco design method. The other parameter or the other method that can be used in the transition could be using alternative materials and recycled raw materials. So, in integrating composite materials into circular economy, the use of alternative materials and recycled raw materials could be very important. These materials could offer a potential to reduce negative environmental impacts. So, biodegradable fibers or bioplastics or some advanced high performance resins could be crucial in at this stage. At the Yeah, on the other part, in the production phase, recycled raw materials could be used. Uh, so when we say recycled raw materials, we mean the recycled fibers or recycled resins. So fibers used in the production of composites can be reused if they are properly recycled. Also, recycled resins could be used in the new composite products if that's possible. So these are the main methods that can decrease the negative impacts of the composite in the industry. So in the transition to circular economy, there are many challenges and opportunities. So, um, for example, supplier selection and collaborations. So companies in the composite industry should select the suppliers that comply with sustainability goals in their supply chain. So these suppliers should use environmental friendly materials and have sustainable production processes. That's one of the steps. The other step is logistics and transportation. So in order to reduce the carbon footprint in material transportation processes, more efficient transportation methods and logistics networks should be used. In addition, localizing material transportation processes will reduce the also negative environmental impacts. Waste reduction and reuse. It's important to minimize the waste generated during production and make these waste reusable if possible. So reprocessing waste or using them in other products contributes to circular economy model. The other parameter regarding the waste is the waste collection and separation. Composite waste should be processed with collection and separation methods to make it suitable for recycling. That's an important parameter, or that's an important step to before recycling. That ensures effective management of waste, and that's also important in the large size composite components. So the advantages of supply chain and waste management will be reducing costs, also encouraging sustainable collaboration, and also reducing waste and increasing recycling rates. These are the main advantages uh, of the process. So when we look at the challenges and opportunities, um, technical challenges are mm, one of them that we can face in the process. So the recycling of composite materials presents significant technical challenges, especially due to the complexity of the material structures and the strong bonds between components. And so these challenges can directly impact the efficiency and cost effectiveness of the recycling process. For example, separation of matrix material is a technical challenge. High quality fiber recovery is another technical challenge because when recycling carbon and glass fibers, so factors such as the length, surface properties, and the durability of the fibers can be affected. That they're very possible. This can lead to low quality fibers that are recovered, and their reuse is only possible in low performance products. So maintaining fiber quality is one of the biggest challenges, one of the biggest technical challenges uh, that can be mentioned in this part. Mixed composite components is also a technical challenge. Composite materials are often composed of multiple layers and different types of materials. For example, composites containing metal reinforcements or polymer binders can complicate the recycling processes. So that limits the recycling efficiency, for example. So these are the main technical challenges. So what could be the solutions to this? So development of new chemical and thermal recycling technologies, for example, and design of new processes that will uh, allow more efficient recovery of fibers could be the solution. So, as a summary, the development in the recycling technology is the main solution for the mentioned technical challenges. In addition to technical challenges, regulation and standards are also important factors. So in many countries, laws and regulations aimed at reducing environmental impacts are becoming significant. So initiatives such as European Union Green Deal include regulations aimed at reducing carbon emissions and encouraging recycling. So the lack of global standards, for example, for composite material recycling processes can lead to different methods used by different companies in the industry. So, for example, currently, since the recycling of composite materials are not very common in the industry, there is no enough regulations and standards. That's why different companies could use different methods to recycle the materials. But this can negatively affect the recycling efficiency and process effectiveness. In addition, specific standards need to be established for the use of recycled materials in products. So I guess these are the some challenges that can be solved with the developed technology and the regulations in the industry. So that's the end of the webinar too. Thank you for joining our webinar.